What's up, guys? Welcome to today's show. So we are creating our own Linux distribution, full scale. In episode 1, we created a tiny Linux version on USB flash drive. So that's going to be our installation image. And on episode 2, we did two things. One, we finished the USB Linux. And two, we created a partitioner, which divides up the disk in a Linux partition and a swap partition. And today we do episode 3. Alright, so episode 3. Today we're gonna do, this will probably be a rather short episode. The last one was about 3 hours, because the only thing we're gonna do, the primary thing we're gonna do, which is also the second thing, that is to create a formatter, which formats the primary Linux partition with the right file system. But in order to do that, we first need to map all the partitions. And what do I mean by that? If you watch the second episode, you know that we currently always create two partitions, one swap, one Linux. So why would we need to map them? Well, I wanna have an expert button where the advanced users can create their own file systems, so their own partition table. And in that case, we need to figure out if we have a swap and how big it is and stuff like that. And we need to figure out which one of the partitions is the Linux disk that we're going to use our formatter on. And before we do all that, I will do a quick bug fix. Let's call this 0.0. Because currently, if we already have a partition table, we will add partitions to that table. That's not what we want. So we want to erase. So that's the general idea for today. And let's begin by figuring out how to erase a partition table using sfdisk. I think it will be rather easy, but let's see. So we have activate, we have add, delete all or the specified partitions. So if we just say delete and the device, we should be fine, right? So let's see what we got. We have some disks here. And if we run sbin, let's do cfdisk so we see a little bit more clearly. And let's see what we got on the XDC drive. Okay, nothing. What about XDA? Alright, so here we have a Linux swap and a Linux partition. So let's see if we can delete this one, XDA. So then we should be able to run sfdisk, delete, and the device. Alright, and if we run cfdisk on this one now, it's clean. Perfect. So now we just need to add this to our script. And this will be the partitioner. So let's see, where do we create? Okay, so this is the line where we create the partitions. So let's first delete them by running sf disk delete and the device. Easy as pizza. Point 0 is done. Very nice, pretty nice. So let's see here. Device. We have this prefix. Do we use this anywhere? No, we don't. Because here we're grepping for XD. Actually, we should grep for the prefix here instead. Like so. Do we have any other XD? No, that's the only one. And let's add a to-do, because I don't want to forget about this thing. Because currently we are dealing with megabytes, because we use small disk images when we test this stuff. So this M should be a G when we do the real thing. So let's add a to-do, change megabyte to gigabyte, and let's highlight this. And if you don't know how to add the highlight stuff to your VS Code, you should get an extension which is called bookmarks, I think. Alright, so let's see, what's next? We need to be able to check through the partitions and figure out, what do we need to figure out? We need to figure out if we have a swap area and what partition that is, and we need to find at least one Linux partition. So let's see, how does XDB look? Here we also have Linux and Linux swap. So this is what it should look like. If we run, let's see, this is XDB. If we run sf disk dump on XDB, what do we get? We get this. So, okay. So this type is interesting here. Type 83 is the Linux. So we want to see, do we have an 82? And which one is that? And it doesn't say anything about partition numbers. So we need to count the orders. So we need to iterate through these lines. That's what we need to do. Alright, so let's create some verify function. So this function should return two words, where the first is the swap device and the second the Linux device. So returns and let's have an IE. So it can be, in our case, XDA1, XDA2, but it could also be none XDA2 or something like that. So that's the idea. Alright. So this verify function will take a disk device as an argument. So let's say we have a, how did we do it in the other ones? We had a local dev. So if $1 is nothing, then return 1, else dev equal to $1. Okay, so now we know if it's XDA or XDB or whatever. So what do we do now? We run sfdisk dump on so we need a full dev path. And we have a dev dir. So dev path is equal to dev dir slash dev. Okay, so on that dev path, we run sfdisk dump, and now we need to parse this thing. So while read x to so now x will be equal to this line here, for example. So how do we get what we need out of this? We can divide it up in words based on the equal sign. So this is first, this will be the second, this will be the third, and the fourth will contain the device and possibly a comma and some other stuff which we don't care about. So let's grep for one of these. Wait a second, we actually have the number here. I've missed that before. So if we know the number, that's actually the only interesting thing. And this, of course. So maybe we should do some sed magic to get the output in a better way. So let's start by grepping for xdb1 here, so we just have something to work with. And this could possibly be an entire path. We need to take that into account. Let's try it without the dot slash. What will it look like? Okay, so then it just looks like this. Maybe we can run base name on that thing. Well, let's start by doing some sed things. So what do we have from the start here? We have the start of line, and then we have a couple of characters. We have anything, and then we have a slash. And then we want to have a capture group here, where we have single word. So this can be A to C, A to Z, 0 to 9. And any number of these. Or let's do it like this. Let's say it's anything but space. Alright, so now we should have captured the first thing here. And then we actually have a literal space. Then we have some other stuff. And then we have type equal to something. Where this something is numbers, 0 to 9. And I guess it's either 1 or 2 or 3 digits. Maybe they can be hexadecimal digits. So let's do A to F as well. And then we might have a comma. Maybe we can just do this. And let's escape these parentheses. And we need to make this a substitution. And we want to substitute the first capture group and the second with a space in between. Something like this. Unknown option to S. Did I have an additional comma here somewhere? Here's one. Maybe we need to escape this. No, that's not it. What am I doing wrong here? You have probably spotted it already, right? Okay, so now we don't get an error at least. But we don't really get a match either. So where does it fail? When I have one of these long Z strings here and I can't seem to find the error, what I usually do is I try to divide it up in two things, or less big things. So in this case, we can break it off here. To something like this. Okay. And if we change foo to the first capture group. Okay, so that one is no problem. So I guess this second one is then. Yes. Maybe I have the wrong format for this. Possibly. Well, we can have any number of digits here. Okay, that was it. So let's see if we can fix the real thing. Okay, we got it. And what if we were to grep for this XDB thing instead? Will that this line, will that bootable thing become a problem? Nope. Nice. So let's copy this whole sed thing. So before we pipe this to while, do the sed. And let's break up this a little bit. Alright, so now we have two words. So let's say we have more local variables. We have a D, which is the device that we are looking up. And the type. So let's say our D is equal to so we cut with a delimiter of space, and we want the first one, this, and we provide our $x. Then we do the same for the type. This is the second word. So let's see if this works this far. So D is equal to D, T is equal to T, and we do one more echo. So let's try this out. So let's just do something like verify XD, what was it called, XDB. And then we exit. Should be like this, right? Right, we need to grep for the correct thing. So what can we grep for to get this right here? Start equal to should only be on these ones. All right. All right, looks fine. So how do we deal with these? What do we want to do with them? We want to have additional local variables, because what do we want to find out here? Well, we want to have a return value for the swap and a return value for Linux partition. And let's default these to none. Alright, so let's see here. We need to check the type first. So if let type is equal to 82, and which one is which? 82 is the swap. So if we discover a swap, and we don't already have one. So we only want to check this condition if ret swap is equal to none, because that way we will only care about the first swap we get. So in that case we set ret swap equal to $D. And if T is equal to 83, and the same condition here, so if ret Linux is equal to none, then we set ret Linux to $D. And now we can just return this by echoing them. So we echo the ret swap and we echo the ret Linux. All right. And what we want to do with this information, we want to do two different things. If we, for the swap, we want to save it to some configuration file so we can use it later on. But the ret Linux we want to pass to the partition to the formatter. Maybe we should add both to a configuration file actually. I think we will. So let's say we have some kind of config, and let's just put it inside of root config. Yeah, let's call it config like this just. But when we are debugging, we don't want it to be at this location. So let's do something like devdir config. So when we have created the partitions, the next thing we want to do is we want to verify So let's see here. Let's say we have some verify data, which is just the verify function applied to disks of our choice. So our verify swap is going to be equal to, so we cut the first word out of the verify data. And then we do the same with Linux, but there we do the second word. Alright, so now we want to write into the configuration file. So we'll just do something like this. We echo swap is equal to verify swap. And we put this inside of the config. And then we have Linux is equal to verify Linux. And we put this inside of our config. And I think that's all we need to do. However, if we don't have a Linux partition, we should fail. How does our error function work? It prints an error. Because we want to go back to the beginning, basically, if we don't have a Linux partition. Is there any go-to in Bash? Guess not. Well, if we messed up the partitions when we dealt with that manually, I guess we can just abort. This is only the first step anyway. So yeah. Alright, Alright, so if our verify Linux is still equal to none, then we do an error bad partition table. You need at least one Linux partition. Something like this. And then we'll just reboot, I guess. Alright, so now our partitioner is done and our verifier is done. All that is left is to do our formatter. And maybe we could make that a part of this thing. Yeah, I think so. So let's see here. What do we have? We have this disk. So if we run cfdisk on xdc, no xd, which was it? xdb. Yes, this is the one. So on xdb2, we wanna try to format that. And in order to format stuff, we have something which is called mkfs, and there are a couple of different, maybe it's an S-bin, mkfs. Here we have. So in our case, we want to do ext4. So let's see if we want to use any specific options. No, not really. So I guess we'll just run this command and we provide our device, which in our case, which was it? XDB. Like this. Found a dose partition table. So what should we have? These are the different options we have, and I'm having a hard time believing that we want to have a sun partition table or a silicon graphics. And this GPT I don't know much about. Let's do a quick Google. GPT partition. Okay, so basically what it's calling a dose partition is actually the MBR. And it's only complaining because this GPT stuff is newer, but on the other hand, I don't like it one bit actually. So I think we're gonna keep the so-called dose partition. But how can we format this without that prompt? Is there a force maybe? No. Ah, so it's a big F. There we go. Nice. So does it still work? Can we mount this thing? But how do we specify that we want to mount a specific partition? Let's do a CF disk on this XDB now after we have formatted. It's a little bit tricky because we are using loopback devices here and they don't really work the same. So we run a little bit into trouble when we try to do this now. But let's try it anyway. So if we try to mount our XDB into foo, no, it will not work. But it will work on our script when we're dealing with real hard disk devices. All right. Alright, so let's format this thing. So we format and we provide the device. And then let's create, let's see what's the make parent directory as needed. So we make dir-p mnt linux, and we try to mount this thing to that. So if we can't mount that, so the type should be ext4, the partition, let's see, it's dev dir, and by the way, it's not device that we wanna format, it's we should create a partition device actually. So let's say partition device is equal to our dev dir followed by our Linux partition. And that's what we want to format. And then we want to mount this thing. So our P device, we want to mount it to mnt Linux. And maybe do one additional check. And let's see if some file or directory there exists. So one thing that we must have is the sbin init. So mnt Linux sbin init must be there. So this if statement is if it succeeds. And in that case, we don't want to do nothing. But if it fails, what do we want to do then? Maybe we can do something like this. We can break if we succeed. And if we fail, we display some message, unable to format Linux partition ver Linux. And then we continue. And then we wrap all of this in an endless loop, so to speak. Well, if this fails, we need to do basically everything all over again. So let's change this. Let's do it like we did before. And instead of continue here, we do the same as here. Otherwise we exit 0. Done. Alright, pretty nice. By the way, forgot to create this format function. But that shouldn't be too difficult, right? So we take one argument. And that's our dev. And in this case, our dev is the entire path to the device for the actual partition, which makes everything very simple. So let's first see if we have an argument here. And when we have that argument, all we need to do is to run makefs ext4-f on the device. And then we return 0. All right, and let's add some info box. Because I don't want to get directly into the partitioner. I want to have one welcome screen or something. So let's say we have a welcome. So we basically do this, but we change it up a little bit. This should be welcome, and we don't need any colors. So something like this. Doesn't have to be more complicated. And this is the first that we'll do. And let's search for back title because I want to change that a little bit. I don't just want to have no bloat Linux, I want to have phase 1 installation. One character too much. Maybe we can cheat a little bit and just do this. And same here. And here. And that's it. All right. By the way, this is a newly formatted partition, so we do not have an S-bin in it yet. However, we will probably have a lost and found. So we can look for that instead. How's it called? Lost plus found. That is some directory which is always created on a Linux partition. This one. I'm not really sure what it's used for. Because it has always been empty for me every time. But it's a good candidate for checking if the disk was successfully mounted. By the way, this should probably pipe any errors away. And when we select the disk here, since it will automatically create the partition table and format the disk. So we should have some kind of warning here. Something like this. Can we put a backspace like this when we are inside of a string? I need to test that. Yeah, okay, good. All right, then I think we are done. We can't really test this because we don't really have any hard disk drive yet. But that will definitely be a next step, because all that is left in this phase 1 installation is to, well, construct some hard disk drive that we can experiment with, and then we want to just copy the files to our real operating system and maybe configure the kernel in just a bit, or let the user do. But that will be the next episode. Today we have successfully created a formatter and a partition verifier. And I really hope you like this episode and this project. Please like and subscribe, and we will continue in the next episode. Thanks for watching. Thanks for today.